Okay, we're going to look at two more example problems using these formulas, and I think you might find the answers a little bit surprising. So after we start talking about these problems, if you want to pause the video and try to figure it out yourself, and then just come back and check your answers, that would be a great idea. So first, if you want to have $1 million when you retire in 35 years, how much should you invest right now if you can achieve an 8% average rate of return? Now, before you pause the video, notice that this question, I actually forgot to put in what method of compounding or how often the compounding periods would be. So let's assume that it's compounded continuously. Okay, and I should have put that into the question. It doesn't make a lot of difference as we've seen, but it does make some difference in the answer. All right, so yeah, you could pause the video and try to set this up and see if you can find how much you should start with, how much you should invest today. Okay, so we want to have $1 million when we retire, so that would be our final amount. So let's put a million as the A. And remember that we are trying to find how much we invest right now. That's the P, right? The present value, or you can call it the principal. So the P. And then we said we could get an average rate of 8%. I mean, that's pretty high. That's not realistic for like a savings account or CDs, the safe investments. You're probably going to get like maybe up to like 4%, depending on how much money you have to invest. Probably more like 1 or 2% though. But if you put things in the stock market and you are a little more aggressive in your investing, then you might be able to achieve 8% over a long period of years. That's still probably pretty high. Most people wouldn't estimate that they could get 8% per year on average. But maybe 6% or so is more realistic. Okay, so we have 8% though is what we're looking at. And then we know that the time is 35 years. Okay, so let's put this into the continuously compounding formula. So 1 million over here. And sorry, I can write that down. A equals P times E to the RT. Okay, so 1 million is equal to P and then E to the 0.08 times 35. Okay, so as we can see, the thing that we're solving for is P. So all we have to do is type in a million and divide it by E to the 0.08 times 35. Okay, so do that in your calculator, and you should have gotten that P is about 60,000. Where did it go? $60,810.06. Okay, so I found that result pretty surprising. I don't know about you, but if I had $60,000 I could put away and not touch for 35 years, I'd be a millionaire after that when I wanted to retire. So that really is about the power of compounding, because your interest is gaining interest as you go through the years. And so you get more and more interest as you go. All right. And then I added this extra problem because I didn't feel like we did quite enough problems where you have to solve for other variables, the ones that are a little more tricky. So this, we have never solved for the rate in this manner before. So I added this in. So it's not on the paper, but you can easily write it down and work with me. What rate will you need to find compounded monthly? So in other words, we're looking for the rate to invest $50,000 if you want to have $500,000 after 30 years. Okay, so you have $50,000 to invest, and you are hoping that in 30 years that will have grown to $500,000. In other words, 10 times the amount. So you kind of want to see, is that realistic? Can I do that? Can I find a rate that would help me achieve that goal if I want to have $500,000 when I'm ready to retire? Okay, so find the rate. Right now, the present value or principal we have is $50,000. And the final amount that we want to have is $500,000. And then we know that the time is going to be 30 years. And this time it does say compounded monthly. So our n is 12, and we have to use the compounding formula. So let's write that formula down. A is equal to P times 1 plus R divided by N raised to the N times T. Okay, so take a look at this formula. Notice that the thing we're finding is R, and we actually have numbers for everything else in this equation. Okay, so if you want to pause the video right now and see if you can figure out that rate yourself. It's some algebra that you do know how to do, but it could be a little tricky, and it's an interesting answer when you find it. Okay, so let's put the 500,000 over here, and the principal or present value, 50,000 over here. 1 plus the rate is what we're looking for, and the n we said was 12. And then that is to the 12 times 30 for the years. Okay. All right. So as we said, we have everything in this equation except for R. All right. So 500,000 divided by 50,000, that's 10. And that makes sense because we said we wanted 10 times the amount of money. And then that's equal to 1 plus R over 12. I can't really do anything with that because of the R. 12 times 30 is 360. Okay, now if you got to this point and you weren't sure how to then solve, great, because you're getting there, okay? Now the issue is this 1 plus R over 12 is what we need to get rid of this raised to the 360th power, okay? It really is as easy as you might think. We're going to raise it to the 1 over 360th power, because then this will be raised to the first power, right? 360 divided by 360 is 1. So we just do that to both sides, and yes, you can raise things on each side of an equation to a power, and as long as you do to both sides, it still stays equal, okay? So that might be the part that you weren't quite confident about. So that leaves this side of the equation as 1 plus R over 12. Okay, because we raised the power and we got rid of the power. This side we have 10 to the 1 over 360th power. That you can do on your calculator. Do that with you. Let's see. Oh, the sun just came out in my room and it is so bright. It's kind of nice though. All right, 10 raised to the. Now, if you have an older style calculator, you want to put a parentheses and then 1 over 360. If you have a new calculator like mine, the parentheses are redundant. You don't actually have to have them, but they won't hurt anything. All right, so that is equal to 1.0064. Okay, so I'm going to write that down, although I'm going to keep that number on my calculator screen. 1.0064. Okay, now I'm solving for R, and now it's a really straightforward problem. Okay, I'm going to subtract 1 from both sides to get the 1 out of here. And then I'm going to have R over 12, so I'm just going to multiply both sides by 12. Okay, I'm writing that down that way because what I want to do on my calculator screen is just keep that order of operations correct. So let's put that over here. Remember what I was going to do? I'm going to subtract 1, and then I'll just hit enter, and then multiply by 12. So times 12 will give me that rate. So I have the rate of 0.077. So R is about 0.077, or approximately 7.7%. That's the rate I'm looking for. So then you can say, well, can I invest my 50,000 that aggressively to get that rate of about 7.7%? If I can find, investments that I think will pay that off, then I should have $50,000 or $500,000 after the 30 years.